Hello everyone, my name is Malek and welcome to my YouTube channel. Today I want to demonstrate how to set up another GitLab CI/CD pipeline to deploy Helm Charts on Kubernetes cluster. In this pipeline, we have a design web page and we will see how to deploy it as microservice containers on Kubernetes cluster by GitLab CI/CD. As you know, in these days, most of the applications are built based on microservices, not monolithic. So each part of application are done by a separate team. Here we assume we were asked to design a login part of application, this one, and we need to test it on Kubernetes cluster. As you see, it is on my local computer. Also, here is the HTML source code of this application. We need to test it on Kubernetes cluster before deliver it and see if it properly works. And at the end of this presentation, with entering the IP address of Kubernetes node and access to this login page. So, as a designer, I designed this HTML page and it is ready to test it on Kubernetes cluster. So, the source code here is on my computer. So, I need to build a container image from the data that I have and push it on container registry. Then on Kubernetes cluster, by running proper manifest, pull image from the container registry and bring up the container here. So we want to do all these steps by using GitLab CI/CD. As you see in this diagram, I'm going to use 3 repositories for this lab, but you can use only one. The first one is using to make a connection between GitLab server and Kubernetes cluster. Here I have created a repository with the name K8s-connection, and also this one acts like firewall, and we can define on it which repository can have access to Kubernetes cluster. The second one is for recording application data and also act as image repository. Here I have created a repository with name K8s-data for this one. And the third one we are going to use for Helm chart repository. So let's continue. For running this presentation, we need to have a GitLab account. It doesn't matter if you are using gitlab.com or your local GitLab server. Also, we need access to a Kubernetes cluster. If you have a cloud account on one of the public cloud providers like AWS, Google Cloud, OCI, and so on, you can bring up a cluster and use that. And maybe these public clouds charge you. Also, there are another choice to bring up a Kubernetes cluster on your local machine. If you are using Windows or Mac machine, you can install and configure Launcher Desktop on your computer. Really, I have recorded a video about how to install and configure Launcher Desktop on Windows machine, and I pinned its link about this video, and by click on it, you can access to it and configure Launcher Desktop on your computer. If you are using Linux Ubuntu distribution or Windows sub Linux, you can use Multipass package to bring up quickly a Kubernetes cluster on your local machine. So these two steps are mandatory to run the labs of this presentation. In the first step of this lab, you have to make a connection between GitLab server and Kubernetes cluster. So to that end, we have to install a GitLab agent on Kubernetes cluster. I search for integrate Kubernetes cluster with GitLab. From the first result, you see a document that is written connecting a Kubernetes cluster with GitLab. If you read it here, to connect a Kubernetes cluster to GitLab, you must first install an agent in your cluster. So click here, installing the agent for Kubernetes. Prerequisite: before you can install the agent in your cluster, you need an existing Kubernetes cluster. As I told you in prerequisite some minutes ago, access to Kubernetes cluster is mandatory. Also, I mentioned if you don't have access to any public cloud provider, you can bring up a local one on your personal computer or your laptop. Here is my personal computer and I'm using Windows, so I installed WSL on my computer and also installed Launcher Desktop. So if you install Launcher Desktop on your computer, automatically you have a Kubernetes cluster. For testing, just type kubectl get nodes and you see the Kubernetes cluster with one node is up and ready to use. So back to document on GitLab. So an existing Kubernetes cluster is ready. So going down, installation steps. To install the agent in your cluster, create an agent configuration file. In the first step, we have to create an agent configuration. To create an agent configuration file, choose a name for your agent. The name must be unique in the project, contains at least 63 characters, and so on. Okay, let's see in continue. In the repository, in the default branch, create an agent configuration file at the root. Let's copy this one. Back to GitLab. In the Kubernetes connection repository that we have created for connection between GitLab and Kubernetes, here it's the root, and just click here, new file, and put it here. Here, for agent name, we have to select a name. So let's select K8S connection. And at the moment, no need to write inside this file and just commit change. You see, we have a config YAML file, and at the moment, we don't have any configuration inside this. Here, it's like a firewall, And in this file, we define which group, which username, which repository can access to Kubernetes cluster. So in next some minutes, I will completely explain what configuration we should define here. Let's back to roots. You see here, we have created a file with this path here. Back to documentation. Here it is mentioned you can leave the file blank for now and configure it later. The next step is to register the agent with GitLab. We have to register that in GitLab at first. How we do that? You must register an agent before you can install the agent in your cluster. To register an agent, we have go to operate Kubernetes cluster. Let's back to GitLab account. From the right side, going down to operate Kubernetes cluster. You see it's empty and we don't have any connection to cluster. Connect a cluster. Just click here, open, and you see the name we have created some seconds ago. Click on it and register. Here give you configuration, and it is mentioned you have to keep this configuration in a safe place, because if you close this page, you will lose this configuration. Agent access token. You can copy this token and use in Kubernetes cluster to make a connection with your GitLab, or you can use Helm. So I'm using this section, but let's copy this one and keep it in a safe place. Let's back to terminal in Kubernetes cluster and run this configuration. Copy the first one and in terminal. Also here, when you bring up a cluster by Launcher desktop, Helm package is also installed. So check Helm. It is installed. So it's already exists here. Helm repo update. Okay, update is complete, and copy the last one and enter. You see, thank you for installing. Your release is named KAS connection. Let's back to our repository on GitLab. Let's close this one. We don't need it anymore. Let's refresh. See, it is connected. So the first step successfully done, and the tunnel between GitLab and Kubernetes cluster is up. Okay, now let's test the connection between GitLab server and Kubernetes cluster. Just in Google type using GitLab CI/CD with a Kubernetes cluster, and from the result, click the first one, and here you see the official document from GitLab. Just go down and you see this one. Update your .gitlab-ci.yaml to run kubectl command. Okay, good. Let's copy this one and going to GitLab server. Here is my repository that's working as an agent between GitLab server and Kubernetes cluster. And this is the file that some minutes ago we have created. So for testing, just we need to create a new file with name .gitlab-ci.yaml because we want to test a CICD pipeline. So based on this document, let's grab this one, copy it, and paste it here. We are using this just for testing. So it is going to use kubectl image from Bitnami because this image have kubectl installed on it. So here we have to put our agent name. Our agent name was K8s-connection. And also we have to find this agent located where? Just leave it as is and we will see what we have to write here. Just commit change and see as soon as we save it, it will go and automatically run a pipeline. So from the left side, going to build and pipeline. Here you see it is failed. Let's go inside that and see what is the reason. Look here, error, no context, because we didn't define the path to agent project. If you look here, when we run kubectl config get context, it will show us the correct path. So let's grab this one, copy, and going to pipeline and replace to this one. So from the left, build and pipeline editor, remove this one and replace it here. This is agent name and this is the path to the project. This is the unique ID of our username and this is the project name, K8S connection. So let's commit change and see if it can connect to Kubernetes cluster and get the list of pods. Click here, it is on running status. Here you see job succeeded and it could connect to Kubernetes cluster and get a list of pods that are running on Kubernetes cluster on default namespace. Let's check it manually on Kubernetes cluster. In terminal, type kubectl get pods. Look here, only we have one pod is running on our Kubernetes cluster in default namespace. If I run kubectl delete pod and the name of the pod, it will go and delete the pod here manually. You see nothing found in default namespace. Let's back to GitLab server. From the left side, pipeline, and run the pipeline again to be sure everything is correct. Click here, it is connected to GitLab runner, and you see no resources found in default namespace. So far, so good. Let's go to the next step. In the next step, let's copy our project data to second repository. So let's back to other repository. As you remember, its name was K8s-data. So at the moment it's empty. Let's clone it back in terminal and just type git clone and the address. ls, let's switch inside that. You see it's empty, git status, and you see it's up to date. What data we need to push on repository? At first, I need to project resource that I designed by HTML, and it is located here in src, ls, src. You see CSS file, HTML, and so on. So to use this project as a container, we need to build an image. As you know, for build an image, we need a Docker file. Here, I created a Docker file, just cat Docker file. Let's clean and open it again. You see, inside Docker file, I'm using Nginx as a base image. To show you quickly, let's bring up an Nginx server by docker run -d -name web001 -p connect port 8082 from my computer to port 80 in the Docker and the image Nginx. Let's browse it by my browser. Local host port 8082. You see, welcome to Nginx. So I gonna use Nginx as a base image to build an image for my project. Let's back to terminal and let's stop this container. Done, and let's remove it. Oh, let's clear the screen. So in my Docker file, as you see here, I'm using Nginx. In the second line, I wrote, hey Docker, please copy my resources from the src folder and paste them in Nginx in this path, /user/share/nginx/html. Let's test it manually, and everything going well, we will use this instruction in GitLab CICD to automatically build an image for us. Let's continue. How to build an image manually? Just type docker build -t. It means add a name and tag to new image that you are going to build. So I'm gonna name it sample and tag it with the version 1, and at the end, where is my Docker file is located, just type dot. It means is located in the root. So just enter. You see this image with this tag is built. Just type docker image ls grep sample. You see in the first line, sample version 1 40 seconds ago was built. So far, so good. Let's use this image and see if everything is correct. So docker run in a state of Nginx, let's using sample version 1. Docker container is built, so let's browse it. Here, if I refresh, you see it's my project. So at the moment, we see how to build an image manually and how it works. Let's back to terminal and stop this one and remove. Nice. The next step is how to push this image to a repository that we can use in Kubernetes cluster. Normally there is Docker Hub and we can use Docker Hub to push our image there. But we don't want to use it because normally every company has its private container registry. So here we're gonna use GitLab container registry as a private registry for our project. Let's back to GitLab, going to left side, and in deploy section you see container registry. At the moment it's empty and we have to push our built image here. At first I show you how do it manually, and in next minutes you will see how do it automatically in CICD. If I going down, you see at first we need to log in GitLab registry. So let's copy this one and back to terminal. Already my credentials are exist on my computer and successfully login to GitLab. But if you are first time login like that, it will ask you username and password. So in first step, we are connected in registry.gitlab.com through CLI. Let's see next step. In next step, it shows us how to build an image. Back to terminal, and let's add sample v1. Image built, just Docker images. You see here, it is built. Let's go in here and show us how to push it to repository. Copy and just sample version 1. You see here, it's going to push the image to the GitLab registry. Here you are. It is pushed to GitLab container registry. Let's check it and refresh this page. You see, it is here. So, how we do these steps automatically by CICD. We don't want this image anymore because we need to push it here automatically. Let's delete it. Delete. Done. Let's back to terminal and copy the project data to the repository. You see, I did copy them in the repository. Let's git status, git add, git commit -am, add project committed, and git push. They are pushed. Let's go in and check repository quickly. You see this folder and Docker file copied here. For CICD, we need create a file called .gitlab-ci.yml. Here we need to define job and steps. Now, how we configure this file? Let's back to Mr. Google, and in Google just type GitLab container registry CICD, and from the result click here and see the proper document for this step. Here, build and push container images to the container registry. Here, this step that we did manually. So we need this section, configure your .gitlab-ci.yaml file. Let's going down. There is some example. Just we need this example, container registry example with GitLab CI/CD. Just copy this one and paste it in the file that we have created on GitLab. Let's back, paste it here. Let's make it more cleaner. Define stages. We define which stage we need to use. So we name it build stage. You can name it everything you want, but for user-friendly, I use build. Here is the name of our job. Change it to image, build image. Which image we're gonna use to run on GitLab runner? We're gonna use the Docker image. Which stage we are using? This stage, build. Which services? Docker. Let's remove this one. Docker in Docker services. What it means? GitLab runner is Docker container, and we're gonna run another container image inside that container. So it's called Docker in Docker container. So in a script section, there are 3 commands. You remember them. The first one is for logging to GitLab registry. The second one for build image, and the third one for push image to GitLab registry. So for the first one, Docker login -u username. There are some built-in variables inside GitLab. Let's make it more clear. Let's copy this one. Which username we gonna use to connect GitLab repository? My username here, my username is, and which password I gonna type my password, and also the GitLab registry address. Instead of writing all the credential in text here, it is better to using built-in variables from GitLab. So let's remove this one. For the username, there is a variable CI registry user. Automatically GitLab determine this one because you are logging in your repository. For the password, also GitLab has your password and no need to define here, just using this variable. And which server, if using this variable CI registry, automatically GitLab will determine it means registry.gitlab.com. It's done this. The first line done. The second one, Docker build CI registry. When using CI registry, as you see also it here, it means registry.gitlab.com. Let's back to terminal and show you something. Remember this command? registry.gitlab.com. Here it's related to my account in GitLab, the name of the repository, and the name of image we're gonna make it. So let's copy this one. Just let's copy it here. The first section will return this one, registry.gitlab.com. So let's remove this one. The other section should be copy and paste it here. So when this line runs, it will create an image with this name for us. And in the third line, it will push that image. Let's copy this one. Where? To GitLab registry. Here also we can add an echo message, image built. Let's save it. As soon as we save it, it will go and run and it will build an image and push it to GitLab repository. Let's add a message by CICD and commit change. This file has been successfully created. Let's back to section pipelines, and here it show you it is running. Let's click it here. Build image. You see here it using Docker executor with image Docker. You see image build. Let's check it. What it happened? Run Docker file, create an image, and then push that image to GitLab repository, and job succeed. Let's go into left side and check deploy container registry and see here the image added here. If I click it here, you see 1 minute ago it was pushed here. So we could build an image and push it to GitLab container registry by CICD. Okay, let's start with create a chart for our login application and see how it works. Before that, let's see how we can create a chart. For create a chart, just type Helm create chart name. For example, Helm create, give it a name. For example, I select this name, test-login-app. Just click enter and it will create a folder with the selected chart name. Let's go into terminal, type helm create test dash login dash app. Enter. The chart created. So ls, you see here a folder with this name created. If I get a tree of this test application, it will show you there are some file also has been created inside this folder. Let's see what are this file. If I back to my presentation, I added a little info about them. In the first line, you see the chart name that we have selected in create command. Also in chart folder, you see a file with name chart.yaml. This file gives us information and description about chart. Back terminal. Let's see the content of this file. In this file, you see API version. The API version that this file is using to communicate with Kubernetes cluster, it's version 2. In the second line, you see name. This is the name of our chart. And in the third line, you see description about this chart. You can add everything in this description. There is another item called type. There are two types of charts. One is application and another one is library. Here, most of the Helm charts are application and the default type also is application. The version, it's about the version of the chart itself, but the application version, it's the version of your application. Okay, so we have created our chart. cd test login application. Let's go inside templates. Here are the default manifests that are located here. Let's remove all the content here and replace them with our manifest. So let's remove all of them. We don't have anything here. Let's back from here. cd this folder, my project manifests are here. Let's copy all of them to test login application and in templates. Let's install this chart on my Kubernetes cluster. How we can install Helm chart? Just type Helm, install, give it a name. Here it's called release name and then chart name. For example, Helm install login application and the chart name, test login application. Let's back to terminal, exit from here, clean screen, type Helm, install login application. This is selected name and chart name dot slash chart name test dash login application. Enter. You see, this is your release name. Last deployed is today. In which namespace? Default namespace. Because in our manifest, we didn't define any namespace and it show us the status is deployed with the revision 1. So let's check if the application deployed on Kubernetes cluster with kubectl get pods. Here you are. This is the pods that are deployed and just get deployment. This is the deployment name and get svc, the service name. It uses node port. If I type kubectl get node, this is the IP address of the node. Copy this address, put it here, double points. What is the port? 31000. Here you are, the application deployed. So for remove the application, just type Helm uninstall release name. Done. If I go and get kubectl get services, everything done. After we prepared Helm chart, we have to push it in a Helm repository. Or in reverse, if we want to install a chart on Kubernetes cluster, we have to add the repository name on Helm. Then Helm can access to that specific repository and pull the chart, then install in Kubernetes cluster. So I need to push it on a repository. Here I want to push it on GitLab repository. Let's go into internet. In Google, if I type push Helm chart to GitLab, from the result, click on the first one. Here will show you how to push your chart to the GitLab registry. As you see here, publish Helm packages in your project package registry. Then install the package whenever you need to use them as a dependency. So for publish or Helm chart, here there is a requirement. Create your own Helm chart. So we have it. We prepare this Helm chart and use it also in Kubernetes. So package a Helm chart into a chart archive. I will show you how to do it. So we can click on this one. There is instruction here and I will speak about it in next some minutes. Let's back. Also for authenticate to the Helm repository, you need a token. Okay, so before pushing our chart to GitLab, we need to package it. Look here, we have to put our chart in a box and seal it, then push it in repository. How we can do it? Just with this command, helm package. Back here, helm package test -login -app. I want to package this chart. Just enter successfully package chart, the chart package, and seal it in a box and also save it here. Let's ls-latr test -login -app with this version 0.1.0. Do you know these numbers come from where? If I go to the chart and open chart YAML, look here, version 0.1.0. So let's clean the screen, exit from this folder, and this is the package we prepared to push it on GitLab repository. Let's back to documentation on GitLab with this command, curl-request post. This is an API command. We want to post this package to where? To our GitLab repository. This is my GitLab account. I wanted to use this repository and publish the Helm chart here. Let's have a look to the command again. Here we have to add our chart name. Here it's our username and our token. And also this is the path for our project, for our repository. Just here we have to add project ID and also select a channel name. For the project ID, we can grab it from here and also we add our username and token here. So let's clean the screen. This is the command that I replaced my username and token and also added project name and channel name here and just enter. You see this message to 100.01 created. Let's back to GitLab repository, and from the left, deploy package registry. Look here, test login application Helm manually published. So far, so good. Okay, for run Helm steps from build package, publish it to Helm repository, and deploy it to Kubernetes cluster, I uploaded chart to Helm project repository. If you see the other files here, just I wanted to keep my files safe here. So just attention to the chart folder. Also you see two Python files here that I will describe you soon. For run CICD pipeline, I am going to create a .gitlab -ci YAML file here. Just click here, new file, .gitlab -ci .yaml. So let's start to configure this file. At first, I did define a variable to save kube context here. In the next step, I put my stages here. In this file, I'm going to use 5 stages. I will show you one by one and describe them. So let's start with the first one, pre-build. In pre-build, I gonna to extract data. What it means. Let's going to chart folder, and you see a file called chart YAML, and I did describe you before. In this file, you see the chart name and also the version of the chart. As you remember, and we did manually, when we package a chart to publish it in Helm repository, the package will use this version in the file name. And also we need the chart name for other stuff. So at first I need to extract this data from this file. So I wrote this to Python file and will extract this data from the chart.yaml. Let's look inside them. This is just a simple Python file. It will go and open the chart.yaml, and it will read line by line and will extract the name and version, and finally in output it show us the version and the chart name. For example, here it show us the chart name, and the second one print out the package name. Let's go into CI file. So as you see here, a stage is pre-built. I am using the Python image to run on GitLab runner, and also in a script section, as you see here, I use 2 environment variable, and it will go run both of the file, and they will be recorded as a key value data in build.env. As you know, when each stage is finished, all the data on that stage will gone, unless you save them as artifacts that can usable in another stages. Normally, we are using file in artifacts, but if we want to pass variables from one stage to another stage, there is a concept in GitLab called .env. If we search on internet for this subject, exporting environment variables from one stage to the next in GitLab CI, you will find some articles about it. So let's going down, and here it is mentioned artifacts.reports.env, and also mentioned pass and environment variables to another job. So if I click here, it will go to the GitLab document, pass an environment variable to another job. Here, give you an example. So I'm using this example. As you see, they save it in this file and uploaded this file as an environment variable in artifact, so it is usable in another stages. But one thing is very important. Look here. Each line must be formatted as variable name, any value here. In each line, just we should have one key value. Otherwise, you will get wrong answer. So let's back to GitLab. So at the moment you understand what I want to do with pre-build stage. So the result that include package version and package name will save in this file and will be uploaded in artifacts. Let's go into the next stage. This stage will create a package from Helm chart that can push on package registry. I called this stage as build. Here I'm using Helm image to run on GitLab runner. Here there are some echo messages. Just I wanted to show you and see the content from the last stage. You see here package version and package name, they comes from the pre-build stage. Also, the main line is here, Helm package, and the path to the package. Package is located where? It's located here. Test login application, and we extract this name from the chart.yml in the pre-build stage. So let's back here. So it will prepare the package, and the next line will push or prepare package to the GitLab Helm repository. You saw them that we did manually. And the last one, just it's a message that shows us chart package published to GitLab package registry. Here you can save this file and will automatically run, and you can see the result before going to add another stages here. Let's save it and run, add CICD file and commit changes. Here you see this GitLab CI configuration is valid. Let's go into the left side and check build pipeline. Let's click here, extract data, finish. Let's see here. Here you see Python file did run and the result saved and uploaded in artifact. And the next stage, it's running to publish Helm package to GitLab repository. Was run successfully. Look here, message 200.01 created. So it means package published to GitLab package registry. Let's go into Helm repository and see what will happen there. Just here, deploy and package registry. You see the package published here. If I click here, you see the package with this name and this version published and uploaded here. Let's back to CI file, add next stages. Here it's a deploy. So at the moment we did publish the chart on GitLab repository, and now it's time to deploy this chart on Kubernetes cluster. So here I'm using this image. Why I'm using this image? Because this image included Helm and kubectl. In the last stage, you see just I use this Helm because I don't wanted to use kubectl, and this image not included kubectl. So I'm using this image, but you can pull this image on your computer and install kubectl inside it and push it to Docker Hub or another repository and use it as your specific image. But here I'm using this one. I found this image on internet. I prefer to use it. So here, as you see, deployment started. Instead of this one, I can use this variable that I have created at the top of this CI file. Just I add these two lines to show you, so this line is not needed anymore. And in the next line, you see Helm repo add. Also, I did show you before how to add a repository in Kubernetes cluster. So with this line, we will add repository, and in the next line, we update repository, and just I use this one to see in the outputs the list of repo. Also, this is not mandatory. You can comment this one also. In the next line, instead of using Helm install release name and the chart, I'm using Helm upgrade -- install. What is different between Helm upgrade -- install and Helm install is if for the first time it go and run Helm upgrade, normally it could find that, so it will go and install it. In the next time, if you run this CI file, so it will check, and if exists, just it will upgrade it if there is any change inside the chart files. So finally, this command will install the chart on Kubernetes cluster, and the last two commands will show us in output a status of the pods and SVC that has created by Helm. Also, there is another stage for destroy the application that we gonna build. So let's put it here, but this one not run automatically. So when you want to run this stage, you can run it manually, and you will see how to do that. So here we have 4 stages. So it seems this one is extra. Let's remove this one. Here you see pipeline syntax is correct and it is ready to commit. Just add a commit message here. Deploy Helm chart on Kubernetes cluster. Commit changes. Let's click on this one. See pre-build stage, build, deploy, and destroy. And each one is running after by another one. The pre-build done, build done, deploy also is done. Let's click here. Look here. Helm upgrade -- install. Look here. Release test -- login -- application has been upgraded or installed. Deployed. Look here. With kubectl get pods, it show us they install and running, and in the services you see test -- login -- svc, the name of the service. So if I go into terminal here, just type kubectl get node dash -oid, here the IP address of the node, grab this one, going to browser, and also let's check the service port. This is the node port, and let's back here and add it at the end of address and enter. Look here. So you see how we did deploy our chart from scratch to deploy it on Kubernetes cluster. Let's back to GitLab and check pipeline. Look here, still one stage is remaining to run. If I click here, at the moment, if I want to uninstall the chart and remove the application from the Kubernetes, just click this one. So it will go and remove the application from Kubernetes cluster by using Helm. Look here, it's done. If I go inside, look here, they are terminating, and also the service is gone. If I back here, refresh page, you see it's gone. So we arrived to the end of this tutorial. I hope you liked it. If you like it, please comment your feedback in the section below. See you in another videos.